So now for 7.2.8, we're looking at a random variable w, which is Gaussian with mean 0, standard deviation 4. Event C is defined as the probability that w is greater than 0, so just the right-hand side, the first quadrant area of this graph. And we're asked, of course, for the conditional probability, w given C, the corresponding expected value, and the variance. And this problem is pretty straightforward. It just really applies our definitions and requires some calculus, so not too bad. And we can actually just write the PDF directly because we know that this area here, so the event probability of C is exactly 1/2 of the total due to the symmetry of the Gaussian. So, right, we can just add a 2 in the numerator for our standard formula for the Gaussian, and that will because we have to divide by 1/2, right? So really underneath there's a P over C, which is just multiplying by 2. And here's x squared divided by 32. Of course, for, well, not x, but w squared. W for all values w greater than 0. And now to grab the expected value of w given C, we again have to apply our calculus. So from 0 to infinity, and now we can rewrite this as, we can pull out the 16 in the square root. E to the minus, we gotta multiply by x, and or not x, but w, right, dw. So in this case, what we need is we need to perform a substitution. So we can substitute v to be w squared over 32, and then our dv would be w over 16. So our integration ends up to be 32 over 2 pi, integrating from 0 to infinity, e to the minus v dv, which actually gives us a very nice result, 32 over 32 pi. Yes, I left the 32 out here. There should be a 32, right? Because 1 minus 0, so the whole integral goes away. And to do the variance, of course, we need to use our variance equation, right? The one that we all know. Expected value of w squared given C minus expected value of w given C squared. So we already calculated this, we just square that. To calculate this quantity, there's a kind of trick we can kind of use. So this is actually over the entire range, w squared times that discussed in Gaussian. And we can kind of realize that due to this w squared and the Gaussian symmetry, this is just this is twice the normal, just the distribution for just w, right? So this makes things a lot easier because this is symmetric itself. So this is just the expected value of w squared, which is sigma squared, which is 16. Because we can use, oh, you can't see, it's sigma squared, which is 16. So that kind of allows us to quickly find the variance. So the variance ends up to be 16 minus 32 pi, which is around 5.51. And that is your variance.